So thanks a lot for joining. Also, hello to everyone watching on demand. My name is Andreas Huber, and today we talk about the power of light in machine vision. So first of all, I will tell you something about Rauscher GmbH. Then we talk about some basics about light. Then how to control the light. And last but not least, I will tell you something about our products and the Rauscher portfolio. So Rauscher is the leading distributor for machine vision products in Germany and Austria. We offer all kinds of hard and software components for machine vision and lighting. On the right side, you can see a list of all our partner companies. If you look down on the left, there is Midopt regarding filter. Then on the left, you see advanced illumination, MBJ, iCore. And also, we offer the Basler lights. Our focus is always on all technical aspects of the application, and we want to find the perfect solution for each case. We can give a huge design-in support, and we also perform feasibility studies. So sometimes, especially when it comes to light, the application, it's very hard because the camera, you can calculate how many pixels you need, how big is my defect, which accuracy do I need, so I can do some calculation and can choose the best camera. But when it comes to lighting, you need a lot of experience, a good feeling. Sometimes you don't know how your product behaves in UV or sphere lighting. So with some special lights, you can get a much better result in your application. Rauscher was founded in 1973 by Ernst Rauscher. So we have 51 years of success in image processing. And at the moment, we have 17 employees. Some basics about light. I think you all know from school. Light is an electromagnetic wave. The visible spectrum is from 400 to 700 nanometers. You can see 500 nanometers is dark blue, 700 nanometers is red. Different literature says you can see till 770 nanometers, so it depends. We also can have a look on the ultraviolet spectrum. It's from 350 nanometers to 400. And also a very special field of lighting is the sphere light from 900 to 1700 nanometers, because there you can see through plastic, water appears black, you can do some welding inspection, so this is also a very, very interesting field. Also, some other basics about light, which is important, choosing the best lighting. In machine vision, you have to take care of the wavelengths. You can distinguish between direct and diffuse lighting. You can use polarized and non-polarized light. This is also a very interesting field. And of course, the angle of incidence is very, very important. In figure A, you see how your material reacts to light. So the yellow one is our light beam. Of course, some light is absorbed, some light is reflected. Also, some light goes through our object, which means it's transmitted. And sometimes with special wavelengths, you also have fluorescence, which is a very important thing. On picture B, you all know from school, incidence angle always equal to accident angle. And on C, you see that mostly the light goes into each direction. When it comes to wavelengths, it affects our reflection, our transmission, and also which wavelengths are absorbed by the material. So on the picture A, you see white light and colored camera. But as you all know, in the field of machine vision, we mostly work with monochrome cameras because the Bayer pattern also affects our accuracy. So picture B shows the same picture like A, white light, but with a monochrome camera. Of course, there you cannot distinguish between red, yellow, green, or the blue candy. But when you have a look on picture C, we illuminate the picture with red light and yellow light, which means the red and yellow candy reflects our light, which means in our picture it appears bright, and the blue one and the green one appears like dark gray or dark. So with different monochrome, with different wavelengths, we can also distinguish different colors. On D, E, and F, you can see some other illuminations like blue and green and mixed. Yeah, as I told you before, polarized light, also a very interesting topic. I think we all know after a rainy day, the sun is shining again, you're driving the car. It's very difficult to see the holes, to see the street, because there is a lot of reflection from the wet street, and it's very, very hard to drive the car. You can use polarized sunglasses, because the good thing is the light is circular polarized. When you use circular polarized sunglasses, you can see everything perfect again. And the same thing we can also use in the field of machine vision. So you need polarized light and polarized optics, and mostly we use linear polarized light. So on the left side you see some example how the linear polarizer is working. You have unpolarized light, then you have a polarizer, and through the polarizer just the linear polarized light can pass. Then on the right side you can see the linear polarized light is hitting an object, is reflected by the object like metal or plastic. It goes through the polarizer in front of the lens, and then you can get some very, very good and sharp image again. Here you see some examples. On the left side you see you have a lot of reflection, you have too much light, everything is like white, and you cannot see through the plastic and inspect your things you want to have a look. On the right side there is the same example, same camera, same lens, same lighting, but with polarized light and a polarized filter in front of the lens. And then you can see the picture is very, very good again, and you can detect whatever you like. You can read the OCR on the top picture. You can have some defect detection on the downside. So you can check everything and you have a very, very good picture again. Another important thing is the angle of incidence. So of course you can have a top light, you can have a backlight. If your light is like 90 degrees to the object, it's called a bright field illumination. If you have like 0 degrees, it's a dark field illumination. And with different kinds of illumination, you can have some different effects on your picture. So first of all, there is an example of a top light. It's a standard dome. The light is very, very close to the object and above. The light is directly reflected into our lens, which means you have a very, very uniform illumination, and it's very good for defect detection. On the right side, you can see the light beams hitting our object is reflected into our lens, and you can have a good picture. In the middle you can see some examples. You see it's very, very bright, uniform illumination, and you can defect like holes or scratches. We can also have a bright field illumination from the back, then it's called a backlight, which means the light of course is behind the object. The light is reflected directly into the lens, which results into very, very sharp edges, and it's good for measurement and good for shape detection. Now on the right side again you can see a backlight application. You can see the holes, you can measure the size of the clothespin, and get some good images. Yeah, last but not least, we also have the dark field illumination, which means the light is like 0 degrees to our object. There, the object does not reflect into our lens. The background is dark. The edges and scratches turn very, very bright. Because if the light from the side hits a scratch, it is directly emitted into our lens again. So it's good for scratch or defect detection. So this was some standard light application: top light, backlight, dark field illumination. So what is the benefit of Rauscher? So we have many experts, we have a lot of experience, as I told you, more than 50 years in the field of machine vision. So we can help you to choose the best light for your application. We can also do some feasibility studies, because as I told you at the beginning, calculating a lens or calculating a camera is very, very easy. You can do some simple math. You have your pixel size, the amount of pixels, and can choose the best camera. But in the field of lighting, it's not so easy. You cannot calculate. So you have to do some tests, and then you can talk to the customer and find the best light solution for the specific application. We also have a very, very big Rauscher light lab. At the middle, you can see Heiko Wirtz from the company Anticipate. There we also had to separate some different things like plastic, and we did not know how our things react to UV light or sphere light, so you can check at our light lab on yourself and choose the best application. On the right side you see our demo portfolio, because often you don't want to go to our office in Olching. You want to do the tests at your laboratory. So we can also send you some sample illumination, and then you can check how your things react to UV light, to sphere light, to green light, to blue light. So you can do the tests on your own. Sometimes you also have some restrictions regarding the size. Then we also can offer custom lights for you. So you need a backlight or a top light with a very, let's say, strange size, because you're very limited in your application. Then we can also do the custom lights for you. And also we offer a very huge range of different light colors. Of course, we offer UV, the sphere lights, but also different kind of blue lights, different kind of green lights, different kind of red lights. So mostly if you go to any other companies, they just have one green, one blue, one red, one white. So we can offer a very, very bright range. Another very interesting topic is how to control the light. So the different LEDs you can operate in different modes. You can use the continuous mode, which means you turn the LED on. By the end of the day, you turn the LED off. Everything is working fine. The next step is you can use the light in gated mode, which means if the camera is exposure mode on, your light is also on. If your camera is off, your light is also off. There, the life cycle of your LED is longer, and you can save the environment. But the very interesting thing is you can also use your LED in strobe mode, which means the camera and LED is triggered by a controller, or maybe the camera is triggering the light. And then for a very short time, the exposure time is on, but you overdrive your LED. You can see here on the right side, your LED is 8 times brighter than in standard mode, which means the exposure time is reduced, and you can reduce the blurring, you can overdrive the LED, and you can perfectly synchronize your camera and light. So one example, you have things on a conveyor belt which is very, very fast. Your camera exposure mode is too long, which leads to blurring on the left side. If you use some controller to overdrive your LED, the exposure time can be reduced, and you can reduce the blurring, and you can get a sharp image again. Another very interesting topic is if you use a conveyor belt, a line scan camera, or also area scan camera, you can trigger several LEDs, different type of lightnings, so one top light, one backlight, two dark field illuminations from the side, and in one movement you can have 4 different type of pictures. We also have this application on our booth, so if you're interested, please have a look on our booth. You can see on the right side we have one line scan camera, we have a backlight, we have a top light, then we move our thing one time, and then you get a picture from the top and from the back side. Here you see some example with a coaxial light, backlight and side light. So in one movement, you get 3 different pictures. Then of course your image buffer, you have to separate your things. And then there is, as a result, you can have backlight, top light and side light. So now let's talk about our Rauscher portfolio. We have a huge range of different lights. So our main partners are Advanced Illumination, Basler and the MBJ, which all have their booth here. So if you have any questions, come and ask, and we can have a talk to them. For the filter, it's always very, very important to choose the best filter for your application. Our partner company is Midopt. When it comes to controller, our partners are iCore, Advanced Illumination, and of course also Basler and MBJ. So thanks for being here today. Visit us at booth C48 here in Hall 8, this side. And let's say it's always better to light than to write, because a lot of people always say, oh, my algorithm is so good, I don't need the best lighting. But please trust me, it's always good to choose a very good lighting which fits your application.